Welcome to Chapter 1, Data Communication Fundamentals. In this session, we will focus on the core concepts that explain how information is exchanged and represented in computer networks. These concepts form the foundation of understanding all networking and communication systems. We began with the communication concepts. Communication refers to the exchange of information between two or more parties. This exchange can happen locally, such as face-to-face interaction, or over long distance using digital systems. In computer networks, this process is known as data communication, where devices exchange information through transmission media using agreed roles. A typical data communication system consists of 6 key components. The first is the message, which is the information being transmitted. The second is the sender, the device that initiates the communication. The third is the receiver, which receives the message. The fourth is the transmission medium, which is the physical or wireless path used to carry data. The fifth is the protocol, which defines the rules of communication. The sixth is the overall system that ensures coordination between all components. For a communication system to be effective, it must meet 4 important characteristics. The first one is delivery, meaning the data must reach the correct destination. The second is accuracy, ensuring that the data arrives without error or distortion. The third is timelines, which ensures that data arrives within accepted time frame and in the correct order. The fourth is jitter, which refers to the variation in packet arrival time that can affect the real-time applications such as video calls and audio streaming. Next, we will move to data representation, which explains how data types of information are converted into a form that computers can process. In digital systems, all information is ultimately represented using binary digits, that is 0 and 1s. Text representation involves converting characters, symbols, and numbers into binary form using character encoding system. Each character is assigned a unique binary code. A common encoding standard includes the ASCII and Unicode, which ensure that text is consistently interpreted across different systems. The other one is number representation, refers to how numerical values are stored in binary format. Computers perform all calculations using binary numbers. In some cases, formats such as binary coded decimal are used where each decimal digit is represented separately in binary form. Image representation involves breaking an image into small units, which is called pixels. Each pixel contains color and brightness information represented in a binary form. Image quality depends on the resolution, which is the number of pixels, and color depth, which determines how many colors can be displayed. Audio representation refers to sound signals such as speech or music. Since sound is continuous in nature, it must be converted into digital form using analog and digital conversion. Digital formats such as MP3 and WAV are widely used to store and transmitting audio. Finally, video representation consists of a sequence of images or frames displayed rapidly to create motion. Video can be transmitted as a continuous stream or a discrete frame. Compression techniques such as MPG and H.264 are used to reduce file size and bandwidth requirements while maintaining acceptable quality. By the end of this chapter, you will be able to explain communication concepts, identify the components of data communication systems, evaluate system performance characteristics, and describe how different types of data are represented in digital form. See you in the next session.